Hello there, welcome back to part 2. And we finished up on this page and I realized I left out one last thing I want to mention on this number 11 here where we had the solutions 4 and negative 4. And remember we're finding solutions which are also called zeros. Let's look back at the equation we had real quick and add this part to your notes. If 4 is a solution, watch what happens when I put 4 in there. 4 squared minus 16, there's a sloppy 2. That's 16 minus 16. See what y ended up equaling? That's y, by the way. It's 0. That's what it is, okay? It's the x-axis. It crosses the x-axis because y is 0 with that value for x. Same thing would happen with negative 4, like this. If we want to know what is y when x is negative 4, well, negative 4 squared is also 16, and that is another 0 for y. So you're looking for the value of x that makes y 0, that x-intercept. There it is. It should all come together, I hope, for you sometime soon, if it's not already. Okay, let's move on. Now, we're going to have to start looking at problems where the answer maybe isn't a nice number like 4 and negative 4. Maybe it's like some crazy decimal value. We're going to see that here shortly. All right, let's look at this page right here. This method, solving using square roots, super simple, but it only works when, basically, well, I'll finish that sentence in a second, sorry. Ax squared plus bx plus c is set equal to 0, okay? So from this equation, this b right here has to be 0 also. So that's a 0. So essentially, this middle term isn't really there. Okay, on the previous problem, did you notice that? Scroll down here. This problem that we just did. Notice that there was no b term in that problem. Okay, notice in this question right here, there's no b term. So we can use this method of using square roots. All right, if you have a b term in there, you're going to have to get onto something that's a little more complicated because that kind of messes things up. Anyway, I'm going to show you real quick how to do this and how simple this is. To solve, to find the solutions. Okay, so notice the directions right here. Follow the steps to find the solutions. That's what you're doing. You're solving it. For m squared minus 36 equals 0. We want to know what value there would make it 0. This is how you do it. Write down the equation. M squared minus 36 equals 0. Now what we would do is we would add 36 to both sides. We're just solving an equation here. All right, now they kind of didn't keep things lined up here. I wish they would have. So we did that, and you would end up with m squared equals 36, which is what goes there. M squared equals 36. Now, in order to solve this, you have to take the square root of m, because the square root of m squared is equal to m. Why? Because m times m is n squared. So if you square root it, you have m. Okay, so if you take the square root of it, perhaps you remember, I hope you do. If not, you better learn it right now. When you take the square root, you get two possible answers. You get a positive and a negative. If I square root m squared, I get positive or negative value. Okay, so the square root of m is, we'll just call that m. That means the 36 can be plus or minus the square root of 36, which could be plus or minus 6. All right, why? Because 6 squared is 36, and parenthesis negative 6 squared is 36. Now, if you're doing this on a calculator, make sure you're putting those parentheses in there, or your calculator might be doing something different. And be really careful, because we ran into a problem with that last week with someone. All right, so that's how you would find it. So the solutions here to this problem is plus or minus 6. Two answers, 6 or negative 6. All right, so moving on to this number 13, it says, well, what are the solutions of 3x squared plus 15 equals 0? Okay, let's solve it. We're going to subtract 15. We do notice that b is equal to 0. There's no b term, so I can use my square root method. I'm going to subtract 15. Sloppy writing there. 3x squared is equal to negative 15. And then we divide this by 3. So that ends up being -5. So we have x is equal to plus or minus the square root of -5. All right, so if we try to find the square root of -5, there's no solution. That doesn't exist. Can you think of two numbers multiplied would give you -5? There are none because it's negative. It's not because it's 5. It's because it's negative. You can't multiply two of the same numbers and get a negative number. Okay, so 14 says, does this have a real number solution? It's no, it does not. No, the square root of -5 is, and it's actually an imaginary number. Yes, that's a real math term. Imaginary number. Cannot multiply to the same numbers and get negative. Okay, so what we found here is basically we found some kind of graph that looked like that. It never crosses the x-axis, so there's no solution to it. Here we can prove it with math without graphing it. Okay, easy. All right, super simple stuff. So let's take a look at this application right here, choosing a reasonable solution. Here's an aquarium. This aquarium is designing a new exhibit to showcase tropical fish, and the exhibit will include a tank. And this tank is a rectangular prism, it's valuable to know, with a length L, and the length is twice the width of W. The height of the tank is 4. The volume of the tank is 500. What is the width of the tank to the nearest tenth of a foot? Well, here I cut the same problem to the next page here with my notes on it, and want to look at this with you through number 15 as they guide us through the problem here. Well, here's what we need to know. You have this prism, right? And you have a height, you have a width, and you have a length. Okay, and to find the volume of this, you need to know this formula. You need to know the equation for the volume of a rectangular prism. It's length times width times height. Okay, well, we know, here's what we know, is we know that the height is 4, right here, and we know that the width is W, right here, and we know that the length is L, but they tell us right here that the length is twice the width. So we also could relabel this L as 2W. Okay? So if the length is really 2W, all right, I can substitute that 2W in for that L and just keep that there, and I know that this 4 is 4 here. And that's what they're trying to tell you in this line right here. Next, I will substitute 500 for V. Obviously, they told you that right here in the problem. And if the length is 2W, that's the length right there. That's the length times W, the width, and times 4. So what I can do now is I can multiply the 4 and the 2, right? Because basically right here you have 2 times W times 4, which essentially is what you have here. That's 2 times 4 is 8, and that W times W is W squared. Okay, so now what we have to do is solve this. Now they kind of skipped some steps here. I wish they would have gone ahead and shown you the solving part. So you're going to divide both sides by 8. So you have W squared. You end up with this. You end up with 500 over 8 equals W squared. So what you're going to do now is you're going to square root both sides. And when you square root that becomes W, which is right here, and that becomes plus or minus. It's important that you put that down there, 500 over 8. And I went ahead and divided that out for you. You can double check me, but I believe it's 7. The square root of 500 divided by 8 is 7.9. Actually, I think it goes on and on. We had to actually round that off. So the zero value for this particular problem is 7.9. And in doing that, you've just found, can you imagine trying to actually graph that value and identify that the x-axis intersecting point with that parabola is 7.9, whatever number it is? You can never do it. That's why we need other ways to solve these equations. Real quick, I want to finish this up here, even though I'm a little over my time. 17, real quick. If we're going to solve these two equations, if we were going to solve this, you copy the problem down and you solve it. So 5x squared minus 50, you would add 50 to both sides. You would divide that by 5. Okay, if 50 divided by 5 is 10, then you square root both sides. You get x is equal to plus or minus 3.16. I think I had to round it off there when I did that. So that's one example. One more example. If you're going to solve this one, you would add 125 to both sides. You got 5x equals 125. X squared divided by 5 is equal to 25. That's plus or minus 5. And that would be the solution for that one. Now they're trying to ask you here, which one is easier? I honestly think this is always easier than graphing, because see how fast you can do that. But the point that they're trying to make is you could graph that one and get the solution, but you're really not going to be able to graph the one on the left and get a solution because that crazy answer there. So that's what they're trying to say here, but I wanted you to see two more examples. Okay, I'm over time here, but that's it. That's all the notes for today. See you soon.